Okay, so now we're done with our algebra review and we're going to get back to working our way up to calculus and rates of change. So we're going to find and interpret the average rate of change, first from a graph and then using algebra. So when we're looking at a graph, the blue graph is the graph of the function f of x. Then the red graph is a straight line connecting two of the points on the graph of the function. And when you draw a straight line between 2 points on the graph and find its slope, you are finding the average rate of change. Okay, so the average rate of change is the slope of the line, the straight line that you draw between 2 points on the graph. So let's look at some examples. These graphs, the first one is just the graph of the Dow Jones Industrial Average over time. Then the second one is the one we're going to look at where we're going to actually answer a question about it. It says the slope of the red line is the average rate of change of the Dow Jones Industrial Average from 2013 to 2015. So can you see that if I draw it from different years, like if I draw it from 2008 to 2010, I get a completely different story. So the average rate of change gives us some big picture information, and calculus will let us dive deeper and get more detailed information. So this graph, we're looking at these 2 points on the graph. So the first point is at 2013, and then here is the data table that tells us the actual Dow Jones Industrial Average number for 2013, the one that got plotted on this graph. Okay, then the second point that we're going to look at is 2015, and the Dow Jones Industrial Average in that year was 17,833. So if I want to know the average rate of change of the Dow Jones Industrial Average over that particular 2-year period, I find the slope of the line. So it's the second y value minus the first y value over the second x value minus the first x value. And I'm getting 2210. So the interpretation of this, which is way more important to me than you can find the 2210, this is the average increase of the Dow Jones Industrial Average over the 2-year period from 2013 to 2015 is this number here. So it's the average increase per year. Sorry, I forgot that part. The average increase per year, because we've divided by the number of years. So then it comes out per year. Okay, so here's another example with a graph. It's enrollment in millions in degree granting public, blue graph, and private, the red graph, post-secondary institutions, so colleges and universities in the United States. And it's projections through the year 2022 of what enrollments will be like. And notice the enrollments are in millions. So if you get a number of 18, it's 18 million. So we're first asked to find the average rate of change over the period from 2010 to 2022. So let's see, this graph goes in 2-year increments, 2000, 2002, 2004, 2006, 2008. So here's 2010. Then I'm going to come up and see that on my graph, In 2010, my number of enrollments was 15.1 million. And then in 2022, I see that we had 16.9 as our projection. That's really it's a guess, but it's an estimate based on modeling. So I want to know the slope, second y minus first y over second x minus first x. And I get 0.15. And then remember that the slope has units of million enrollments. This is what y is being measured in per year, what x is being measured in. Well, this is the average increase expected over this 12-year span, 0.15 million enrollments per year. It's a positive number, so we're expecting to see an increase. Okay, and I'm pretty sure you have the B part to do for a homework problem. Okay, so we're almost to the calculus part. One more preliminary step. We need to be able to find the average rate of a function if all we're given is the equation of the function. So we were looking at graphs first. Now we're looking at equations of functions. So if I want to find the average rate of change for a function, I need to find the value of the function at the upper x value minus the value of the function at the lower x value divided by the difference in the x values. So let's do it piece by piece. In this problem, x equals 0, that's the A. X equals 6, that's the B. So f of B is going to be f of 6. So that says put 6 everywhere you see an x in for the function. And that's going to give you 48. So that's my f of B. And then I need to find f of A. So f of 0, well, that's going to be pretty easy. That's 0. So now I want to find the average rate of change, and you can abbreviate that if you like. So it's going to be f of 6, 48, minus f of 0, 0, over 6 minus 0, so it's going to be 8. Okay, so that's the average rate of change. Now the thing that we're going to add in this last objective here, that's the calculus part, is we're going to find the instantaneous rate of change by letting that different distance between A and B get smaller and smaller and smaller. So we're going to call that distance between A and B h and find the limit as it goes to 0. Okay, so here's my function, x squared minus 3x. So the example breaks it down for you, and it says first find f of a plus h. So we've done kind of a lot of practicing of what if I plug weird things into the function? Okay, it just means I take a plus h, gathered together as a single quantity, and drop it into the function everywhere I see an x. Okay, then I want you to do all the algebra that you can and get rid of all the parentheses. So remember that a plus h squared means a plus h times a plus h. So when I square it, I need to FOIL and get a squared plus 2ah, because remember ah and ha are the same, plus h squared minus 3a minus 3h. So that's part A. Just find the f of a plus h. Now put this together, and this is called the difference quotient. So the f of a plus h is the piece we already found. So it goes right here in the upper left. So a squared plus 2ah plus h squared minus 3a minus 3h. So just copy that. Then whenever you have a minus, open a parenthesis, because that minus needs to get distributed to everything that comes after. Okay, so now we need f of a. Well, here's f of x. So f of a says put a where the x is, and then put it in here. A squared minus 3a. And then this is all divided by h. And you should have lots of things that cancel here. So you're going to have a squared plus 2ah plus h squared minus 3a minus 3h minus a squared plus 3a as I distribute that negative through. And then look for everything that cancels. So I see an a squared and a minus a squared. I see a negative 3a and a 3a. Everything that's left at this moment needs to have a factor of an h in it. If it doesn't, something went wrong and you need to back up. So now factor out that h from each term in the numerator so that the h's will cancel. And then to find the instantaneous rate of change, because this is still average rate of change we're looking at, now you're going to find the limit as h goes to 0 of 2a plus h minus 3. And this is the instantaneous rate of change, if you want to give it a name. As soon as you put the limit as h goes to 0 on it, then it's the instantaneous rate of change. Okay, and then remember the first thing we always try with the limit is, let me put in 0 for h, and if nothing bad happens, then that's my answer. So let's see what happens if we put in 0 for h and we just get 2a minus 3. So this is our instantaneous rate of change formula. Then the last thing that you were asked is, what is it when a is 5? So when a is 5, the instantaneous rate of change is 2 times 5 minus 3, or 7. Okay, so you might need to walk through that several times, but you have some homework problems so that you can practice doing that. And remember to look in the back of the text for the answers to all of the problems, or they're also posted in Canvas and in the modules. So our most common interpretation of the instantaneous rate of change will be the marginal quantities. So the instantaneous rate of change of a cost function called marginal cost. If we start with a revenue function and we find the instantaneous rate of change, that will be marginal revenue, and then we'll also have marginal profit. So I wanted to show you an example where you have to really think about how everything's being measured. So the owner of a food truck has found a cost function in hundreds of dollars. So I like to make these notes big and visible for myself so they're not buried in the text, of making X 100 sandwiches. So if X is 3, that's 300 sandwiches. If 9, that's 900 sandwiches. Okay, just to make sure we're clear on that. So here's our cost function. And technically we should do an instantaneous rate of change to get a marginal cost function. I did that work for us, so we could just have a marginal cost function, because this one's kind of hard to do without the rules that we'll learn later. So this is the instantaneous rate of change of cost. Of the cost function. Okay, so that I did for you, found the marginal cost function. Then I want to focus on the part B. If the food truck owner is currently making 1,000 sandwiches per week. So now X is, so let's think about that. X is in hundreds of sandwiches. So if X is 10, that's 1,000 sandwiches. So 1,000 basically. So if he's currently making 1,000, and we want to find the approximate cost of making an additional 100, so the story we're looking at is production will increase from X equal 10 to X equal 11, right? An additional 100 sandwiches means X just goes up by 1. Okay, so the way we're going to find this quantity is we're going to say, what is the marginal cost when A is 10? So A and X are basically interchangeable here. So I have 910 over 2 times 10 plus 40 squared. And I'm getting about 0.25. But remember that the cost was in hundreds of dollars. So this is in hundreds of dollars. So here is the interpretation sentence that goes with what we just did. When you're finding marginal costs, it's approximate. So it's the approximate cost for increasing, and actually, let me say this better. The approximate increase in cost for increasing production from 1,000 to 1,100 sandwiches per week is $25, because 0.2500 is a quarter of 100, so that's 25. So the approximate increase in cost, whatever it was, it's going to be $25 more if you increase your production from 1,000, X equals 10, to 1,100, X equals 11. So study this sentence, practice writing them for the problems in the homework, and that's the end of section 11.3.